Hello everyone, welcome to In 5 Minutes. In this video, we are going to see about discrete Fourier series representation. A periodic discrete time signal with fundamental period n can be decomposed into n harmonically related frequency components. So let us see what is a periodic signal. So consider, let x of n be a periodic signal, where n plus n represents that it repeats after equal intervals. The Fourier series representation of x of n consists of n harmonically related exponential function. So let us say e raised to j 2 pi k n by n, where k ranges from 0 to n minus 1. So the representation of periodic signal becomes x of n is equal to sigma k ranging from 0 to n minus 1 ck e raised to j 2 pi k n by n, where the ck stands as coefficient of Fourier series. Ck represents n distinct Fourier series coefficients. Fourier series coefficients are periodic in nature, but we should understand that they are different from continuous time Fourier series, which has infinite number of coefficients. In discrete time Fourier series, there are finite number of coefficients. X of n can also be represented as equal to sigma k is equal to 0 n minus 1 ck e raised to j omega k n, where omega stands for fundamental frequency of x of n, where omega 0 is equal to 2 pi by n. For finding the harmonic frequency of x of n, that is kth harmonic frequency, omega k is equal to omega 0 k, that is 2 pi k by n. Now finally we see the coefficient of the Fourier series, that is represented as ck is equal to 1 by n sigma ranging from n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi k n by n, where k ranges from 0 to n minus 1. These coefficients represent the amplitude, that is mod of x of k versus k plot, and also the phase plot, that is angle of x of k versus p. Now we are going to see an important property, that discrete time harmonics are not always periodic in frequency. So let us see that as c of k plus n is equal to c of k, as coefficients are periodic in nature. So let us see what does c of k plus n represent, that is equal to 1 by n sigma n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi k plus n, that is capital N upon n. Now we should expand this term and we get 1 by n sigma n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi k n by n and e raised to minus j 2 pi n. Now we are seeing that e raised to minus j, we can see about this term as it is different from this term. So let us expand this term, that is e raised to minus j 2 pi n. E raised to minus j 2 pi n is equal to cos 2 pi n minus j sin 2 pi n. As we can see that it tends to cos 2 pi, which is the value 1 that exists always, and sin 2 pi is always 0. So this value will be 0. This value will be 1. Therefore, if we see this term, it exactly represents c of k. Now, Fourier series is only possible if f is equal to k by n, which is a rational number. Now, consider an example that x of n is equal to cos of root 2 pi n. And if we check here and if we compare with 2 omega, that is root of 2 pi, so it gives 2 pi f is equal to root of 2 pi. That results equal to f is equal to 1 upon root 2. That is not a rational number. So the signal is not periodic. Therefore, this proves the statement that discrete time harmonics are not always periodic in frequency. Thank you.